Okay, lesson number 2 for this week is arc length and evaluating trig functions in radians. So arc length is a chunk of the circumference of a circle, but it's measured in degrees. It's how much degree space, well, technically we can also measure it in radians since we talked about that in the last unit as well. So for what we're going to do for a lot of this is because it's easier to measure arc length in radians, we're going to do some conversion practice just like what we did in the last lesson. So the formula for arc length is S equals R times theta. Theta is going to be our degree in degrees it's our angle in degrees typically. And then radius is whatever the radius of the circle is. So we want to find the arc length with a radius of 5 centimeters and a central angle of 45 degrees. So S equals R times theta. We know that R is 5 centimeters. Theta, however, we don't know just yet. We want to convert that from degrees into radians. So if you remember, to do that, our degrees is 45 over 1. We always put the degree over 1. And now, since we want to convert it into radians, we're going to put pi over 180. And we're going to multiply these. So we get 45 pi over 180. This reduces. 45 actually goes into 180 perfectly. It goes in there 4 times. So we get pi over 4. So theta is pi over 4. So now what we're going to do is we're going to go plug both of these into our formula. So S equals 5 times pi over 4. You can type this out into your calculator. You can type in pi as 3.14, or you can just leave it as 5 pi over 4 centimeters. I am good with that. I'm sure that we can all handle typing in pi as 3.14 and multiplying this out, but I'm good with that answer right there. Same thing here, same formula. Gives us a radius, r equals 12. And this time theta, we don't know just yet. It's 120 is our central angle, so we got to convert that into radians. So 120 over 1 times pi over 180, same conversion. 120 pi on top, 180 on the bottom. 120 and 180 have a common factor of 60. So if you take 120 divided by 60, you get 2. 180 divided by 60, you get 3. So we get 2 pi over 3. So that is going to be our theta. Theta is my favorite variable, by the way. Fun fact. So r equals 12 inches, theta equals 2 pi over 3. Let's plug that into our formula. S equals 12 times 2 pi over 3. 12 is going to affect the top, so it's going to be 24 pi over 3, and then we can reduce that to just 8 pi. Again, you can type that in your calculator, or you can leave it in terms of pi, which I'm totally fine with. So 8 pi is going to be our arc length on that. All right, the next part of this, evaluating trig functions with radians. So when you evaluate trig functions, there's some cool stuff that we're going to do. This is going to relate back to the special right triangles. But in order to evaluate these, what we need to do is actually convert everything into degrees. So now we want to go backwards. So if we want to evaluate this trig function for cosine of pi over 6, we need to figure out what pi over 6 is in degrees. Pi over 6, so now we're using the other conversion factor, which is 180 over pi. Pi's are going to go away. 180 over 6. When you divide that, you get 30 degrees. So we can figure out what the cosine of 30 degrees is. Now, you could type this in your calculator. You can go ahead and try that and get a nice answer. I'm not going to stop you. But if you want to do this by hand, and if you want to learn what I'm supposed to be teaching in that sense, because this is a concept you would have to do by hand, draw a special right triangle that involves 30 degrees. And if you think back, we have the 30, 60, 90. So let's say this is our 30 degrees up top here. This is 90, which leaves this to be 60. If you remember the special right triangle relationship, 30 degrees goes with the smallest side. Whenever we're making our own special right triangle in these examples, and you're going to need to know this for later on, across from the 30 degrees, we're going to make that 1. So that's just going to have a value of 1 across from the 30. And then the hypotenuse is 2 times bigger than the short side. Since this is the shortest or the smallest side, the hypotenuse is 2. And then the last value across from the 60 is going to be the square root of 3. Okay, and we can use the Pythagorean theorem to prove this. This is just the values that we're going to use every single time. So cosine, remember cosine is the adjacent over the hypotenuse. Since it's cosine of 30 degrees, adjacent would be square root of 3 and hypotenuse would be 2. So square root of 3 over 2 is going to be our answer. If you type this in your calculator, you get, if you type in cosine of 30, you get 0.866025, some other numbers. Type the square root of 3 divided by 2 in your calculator, and what do you get? If you get the same thing, divided by 2, which you should, you get 0.866025, so forth. Same decimal. So, there is our answer for that one. This one, evaluate the trigonometric function using calculator. I should say using a calculator. I made these notes. You can blame me. Sine pi over 5. Evaluate the trig function for this one. So the reason, you'll see after we convert this, why we have to use a calculator. So pi over 5, 180 over pi. Pi's going to go away. 180 over 5 is going to give us 36. So we're trying to find the sine of 36 degrees. Good luck using a special right triangle because one does not exist for that. That's why for this one you do need to type it in your calculator. So this, if we round to 4 decimal places, 0.5878 would be the rounded answer. That's what we would get. So you don't have to make a triangle for this one. If it says use your calculator, that's probably because you can't solve it a different way. Some of these you just have to have a calculator for. So number 6, evaluate the trig function using a calculator. So another one here, cotangent of 5 pi over 8. Let's go ahead and figure out what 5 pi over 8 is. So we're going to take it times 180 over pi. Pi's are going to go away. 5 times 180 should be 900. But when you divide that by 8, you get 112.5. So that's not a nice number that we could use for a special right triangle. So this one, again, we're going to need our calculator. This is cotangent, though. Cotangent is the reciprocal of tangent. This is technically the same as 1 over the tangent of, I'm going to use the new value we just found, which is 112.5 degrees. This you have to type in your calculator. So 1 divided by tangent of 112.5, we get negative 0.4142. Interestingly enough, probably questioning, well, how did we get a negative number? It's not because you have your calculator set in the wrong mode. If you're doing this correctly, your calculator should be in degree mode. It's because it's greater than 90 degrees. And if you think back, you've probably never taken sine, cosine, or tangent of a degree angle that's bigger than 90. And in the later lessons, I'm going to explain why it is that we get negative values. But for now, just know that it is okay to get a negative answer for this problem. Last one, evaluate the trig function for secant of pi over 4. Excuse me. Pi over 4, we did earlier. I'll quickly go ahead and do it again. Convert this to degrees. 180 divided by 4 is going to give us 45 degrees. So the secant of pi over 4 is the same as the secant of 45 degrees. Now 45, hopefully you guys recognize that that is a nice number we can use for a special right triangle. So the relationship with the 45, 45, 90 is that the legs are going to be the same, and then the hypotenuse is the leg times the square root of 2. So for the legs in this example, we're just going to say they are 1, and then 1 times the square root of 2 gives us square root of 2. Okay, so it doesn't matter which 45 we use for this. Either one, it's going to give us the same thing. But secant is the reciprocal of sine, or excuse me, the reciprocal of cosine. So if cosine is adjacent over hypotenuse, we need to figure out the hypotenuse over adjacent. So I'm just going to go ahead and label this. Here's my adjacent, here's my hypotenuse. So that means that we have the square root of 2 was on top, because that's the hypotenuse, over 1. And anything divided by 1 is just itself. So our answer for this problem is the square root of 2. All right, so the biggest thing is, for this lesson, when you want to first convert into degrees, make it something you're familiar with. If you get a degree answer that is not 30, 60, or 45, that means you're probably going to have to use your calculator, because we can't figure out specific trig values for 32, for 12, for 57. It has to be a part of a special right triangle if we can do it by hand. Okay, if you have any questions,